Hi, welcome to the companion video for your homework. So we're going to briefly go over the various parts of your assignment. We are assuming that you've already, listened to the lectures, watched the lectures, and also read the assignment. So let's go and dive into it. So here's your maze class, right? We can you create a grid. Maze grid panel, which is this class, which we'll be getting into just a second. And you pass it the number, how big you want the maze. So you want how big you want the maze to be. So we wanted it 5 by 5 because that's pretty easy to follow. Doesn't really produce too many interesting mazes that often, but it makes it pretty easy for you to debug or go move up to a 10 by 10. This line just simply says make it 800 by 800 pixels big. Automatically close when I hit the X button, pack it up for the user, set it visible, and then run it. So you will run this class in order to run your maze. This is where the main amount of the work is. You've got our maze grid panel. It has rows and columns, which are basically how big the maze is. So that's essentially what gets passed in over here. And then you've got a 2D array of cells, which is our third class. This is the extra credit assignment. Read up on it if you want to try it, but it's generating maze rather than solving it. This is your homework. I give you a bit of starting code to work with. So, and what it does is colors this corner up here green, this corner down here red, and we want to get from the green corner to the red corner. Okay. And right over here you can see how to color a cell, but I described that in the lecture and in the cell program on its own. And then we start by pushing this onto the stack. And so you're going to have to figure out the logic for the rest of this assignment. I also gave you the breadth first search that we did in class to solve the maze using a cube. But that's breadth first search, and you need to do depth first search. And you'll want to follow the algorithm that I posted on the assignment. So this is a simple Boolean statement that I check whether or not this has been visited. Takes in a row and a column of the cell you'd like to know whether it's been visited. So we grab it from the maze, check its background, and we consider it to not be visited if it's a white background, which is the default background, or color, which is our red. Or if our color's red, which is our finished cell. If it's not been visited, we return false. Otherwise, we're just going to return true. So so you can use whatever colors you want to mark your statuses. So generate our northwest maze. This is what the code I used to generate my maze, and as we've discussed, removes the north-south walls over here, the east-west walls over here, and then for every other cell, it asks it to flip a coin, and depending on how it lands, it will remove its east-west wall or its north-south wall. Okay, this is the constructor for it. It just simply says set the size of the frame, please. Set the rows equal to the passing rows, the columns equal to passing columns. Create a layout that's a grid layout that has rows and columns. So as we add the cells, they'll be laid out in a grid rather than like all in a row or something. Then we initialize the maze array, and then for each of those, that's a bunch of null values right now. So for each of those put an actual cell there, create an actual cell for that row and column, and then add that maze that cell to the panel. So, and then that will automatically get laid out in a grid for us. And then we call generate the maze and then solve the maze. So now to go onto the cell, which you really don't have to adjust, but it's useful to read this, especially if you're doing the extra credit. Cells have 4 walls, which by default are true, and then it has a row and column, which make it very easy for you to grab what the row column you're in. So you don't have to like work backwards. Right, so over here, right, So I can simply, if I have a cell, I can ask what its row and column are by just using, let's see over here, c.row, since they aren't private. So this is useful if you're just trying to figure, if you need to reference it. These paint the walls. So the paint component, this just paints the walls for here. This is the constructor where we've got a row and a column, and it just sets row and column up, sets it automatically to be a white cell, and then all the walls are up. And then this was actually unneeded because that was me, again, messing around for the first time with this. So that's the homework. The assignment is that you basically will be able to trace a path from here to this corner.